Are you 16?
I was just I just realized that I missed to tape the last few minutes. Sorry about that. Okay, just turn it on again. Sorry, forgive me. You're saying something?
Are you 16?
3 times 6 is 18. 3 times 1 is 3 plus 1 is 4. I always go back and check if there is anything. Is that okay? So far, so good? Perfect. Now remember the strategy. I have to go to from the top. Is it in descending order? It's a binomial. It's in descending order. Greatest common factor that I cannot get rid of. X squared. Very good. Awesome. What is left in parentheses?
X squared minus 16.
Now I'm looking at x squared minus 16. Can I factor that? Yes. Special product. I hope for a special product.
Minus 4x plus 4.
Perfect. I'm waiting for 4 solutions. I don't know how much I didn't record, but it's probably about 5 minutes.
X squared has 2 solutions, right? So x equals 2.
Excellent. Twice. Excellent. You'll see what happens in the next chapter with this.
X equals positive 4 and
Negative 4, negative, positive 4.
Excellent. So these are the 4 solutions. And this is the way we solve a polynomial equation. We can look at another polynomial or move on to radical equations. Very good. Ben, you're in charge.
it's for a radical?
Not yet. The demand was another polynomial.
3x to the third plus 2x squared equals 12x plus 8.
Very good. What type of equation is it? Because we know a lot of types. We know linear, we know quadratic, we know rational, and we know polynomial now. We know 4 types at this point. What type is it? Polynomial. Very good. What is its degree? 3. Very good. Degree 3. How many solutions do you expect? Mandatory. Even if they repeat, it doesn't matter. 1, 2, 3, 4. Very good. So what do you recommend we should do first? Of course. Absolutely. So 3x to the third plus 2x squared minus 12x and minus 8. Go back to the strategy. I only have one possibility for the polynomial. What is it? You have it right there in front of you. What is the only chance for a polynomial? The only method available to us? I have my whiteout in my hand, so what's the method? By? That's it. So from the first 2, you factor out what you have in parentheses. What do I have to copy from the other 2 without even looking? I'm just making a point. You don't really have to do this, but in case you have any doubts, I highly recommend use this, right? And you will not make a mistake. Excellent. So then the common factor is? But I know from factoring that x squared minus 4 is factorable. How do I do that? How do I factor that? And now you're going to give me 3 solutions. I'm ready. when you are.
Negative 2/3.
X equals negative 2/3. Awesome from here. Very good.
Positive 2.
Excellent. Are we feeling better about polynomial equations? Can we move on to the next type, which is radical? Because Ben is dying to give us an example here.
And it's dying. Good.
Perfect. I'm ready. Give me a second to present a little bit of theory here. And then we choose. Let's say I have x equals 2. And you can say, what is this? You're talking about radical equations, and you're starting with what type of equation?
Here.
Right. So what are you talking about? Just bear with me for one moment. Let's suppose, for whatever reason, I decide to square both sides. Although you will say you lost your mind, this is not what we do. The equation is already solved. X equals 2. You're done. Why are you squaring? I'll say, no, I didn't lose my mind. Just bear with me. So then I will write x squared equals 4. So I decided to square, although this is not what we normally do to a linear equation, right? But I decided to square, and now I'm asking you, the initial equation had how many solutions? The new equation, after I squared both sides, has how many solutions? Obviously, one of these solutions doesn't work in the original problem, because this one has x equals 2 and x equals negative 2. So I started with x equals 2, which has only one solution. I squared both sides, and I got two solutions, but one of them has no meaning here, has no place in here. This is called extraneous solution. So I'm okay. I'm allowed to square both sides, but this is not 100% legitimate operation. I may come across solutions that do not work in the original problem. So when we look at radical equations, we are going to use this method. This method is for radical equations, not for what I showed you. The only point I was making here is to show that when we square, since we have no other choice, we have to square, that is not 100% legitimate step. What does that mean? I solve this equation, but the new equation I get may not have the same solutions with the one that I'm solving for, x. So I have to go back and check. That's why I put that stunt in here for you, to always remember that when we square both sides, and we get 5 and 15 as the final answer, both or one may not work in the original problem, because I squared. And squaring, look what happens. Anything can happen. So the solutions we get, we have to go back and check in the original problem. That's why I use this little explanation. So please keep that in mind. Mandatory check solutions when we square or cube or take to the fourth both sides. So now I'm ready. So this is radical equations. Sorry for the wait, Ben. I'm sorry.
Okay, so square root x minus 5 minus square root x minus 8 equals 3.
Okay. Well, I have to say that we'll have to vote whether to allow Ben to pick problems moving forward. Because this is level 3. I thought he was going to give me level 1 first, but he gave me level 3 already. But I can't start with level 3. Let me start with a simple example, and then we'll get back to level 3. So here's a simple example. Give me one with just one radical and no x on the other side. Just a simple one, and then we'll come back to it. I promise. Today, we'll solve that.
Square root 20 minus 8x
8x,
and no x on the other side?
no x on the other side.
Oh, crap.
But you can make one up. This doesn't work like that.
It's 5
equals 5. Is this correct?
You said I can make it up or not?
No, I don't think you can, but that's okay. We'll try it. So this is, it's going to be okay. So the square root of 20 minus 8x equals 5. This is a radical equation. The only chance we have to eliminate the radical is only if we square both sides. So we square both sides, and can anyone give us the right-hand side? 25. Can anyone give us the left-hand side?
29
Excellent. So now this is a simple linear equation. I will have to move 20 to the other side, subtracting 20, and I divide both sides by negative 8. I cannot put enough question marks. Why? So I have no idea. I squared. This is not a legitimate operation, 100% legitimate. It's legitimate. I have no other choice, but it's not 100%. I don't know if this works. This is what I got, but I have no idea if it works or not. So I go back and check in the original problem, not in the one with the square. This is not the original problem. So I put the square root of 20 minus 8 multiplied by negative 5 over 8. And I'm asking myself if that equals 5. If the answer is yes, then I'll go back to negative 5 over 8. And I say, yes, that's it. But if the answer is no, then I'll say, oops. It turns out that it works. How come? Because negative 8 with negative 5 over 8, well, you simplify 8 with 8, and you get 20. This is positive now. 20 plus 5 is 25. The square of 25 is 5. So it turns out that this is a yes. I checked. It works in the original problem. Now, there is another intermediate level between this and this, but I promised then that I'm going to come back to this. This I'm not going to put on the test or the final exam, but so just watch and relax. I think it's really not needed. One radical is good enough. Okay, so I'm going to show other examples next time, but let me finish this problem. Every time I'm asked to solve a radical equation with two radicals in it, it is easier before I square to move one radical to the other side, to separate the radicals, if I have two. And you can say, what about 3? I have no choice. If I have 3, 2 are on one side and 1 on the other. You're not going to see 3 in this class. You're not going to see even 2, not even 2. But there may be problems in my math lab that you encounter. So the first step is I'm going to move this term to the other side. So I have the square root of x minus 5 equals 3 plus the square root of x minus 8. And now I square, of course. That's my only way out of this. So this is x minus 5. And this is a binomial. And I have to square it. And I have to be very careful, step by step. I square the first term. Plus 2 times 3 times the square root plus the second term squared. So the right-hand side is just this squared, the first term squared plus 2 times the first times the second plus the second term squared. Now I separate again the radicals, so the square root of x minus 8 stays on the right-hand side. This moves, and this moves. Luckily, the positive x with the negative x go away. The 9 minus 8 is 1. When I move it to the other side, I get negative 6. So 9 minus 8 is positive 1. When I move it to the other side, negative 5 minus 1, negative 6. Finally, of course, I will divide both sides by 6. To make it as easy as possible. And of course, this is impossible. The square root cannot be negative. Let's say I don't notice that and continue to square. And I get 1 equals x minus 8 or x equals 9. But when I go back, it's not going to work. Let's try. 9 minus 5 is 4. The square root of 4 is 2 minus 9 minus 8 is 1. The square root of 1 is 1 with minus in front. And this will never ever equal 3. I knew that from here because the square root is always a positive. You will not see, I promise, you will not see radical